how many days it is till her birthday. It's not till June. So then we have to go through like counting all the days of each month, and eventually we get there.
I see many people are joining. Welcome. Welcome, usual suspects. Welcome, Alexei. Welcome, Ellen. Nice to see you. Andrei, Arman, Artin, Benjamin, nice to see you. Bernardo, Rhys, Daniel, Diana, Ilias, Lucas. Let's ask people from which place.
Yeah, where are you all from? So got Italy, Moldova,
London.
London is me.
It's you, Mark.
London is me, yeah. Who is coming from the most east? What's the most east we've got so far? I guess Moldova is the most east. Okay,
Ljubljana.
Philadelphia is the most west.
Warsaw,
Maybe Warsaw is more east, actually.
Copenhagen. I have never been in Ljubljana. Probably we will have to host a meetup there.
Yeah.
One day.
So Copenhagen's our most north at the moment.
Bilbao. Nice place.
Bilbao. Russia, there we go. The most east. We're probably Russia now.
Maybe Japan. Someone.
Yeah, if someone in Australia is awake somehow at like 3 in the morning.
Maybe Papua New Guinea as the most eastern.
So we just give people a few more minutes, so maybe one more minute, and then we can do this. So
yeah, just 1 minute. If you want to tell your friends to join the call, you can send them a link to YouTube. We have live streaming, and you can ask questions in Zoom. You can ask questions in YouTube as well, and hopefully they will be answered. Sometimes they will be answered from me, by me.
all right, shall we start then? Let's do this.
Yeah, let me start. So what do we have? This is ClickHouse New Year release 25.1, the first release this year. And we have a lot of features. I will spend almost all the time telling about every new thing that we have implemented. We have 15 new features, 36 performance optimizations, and 77 bug fixes. So let's start and see what do we have as small and nice features. And the first one is the ability to specify subcolumns directly in table keys. So let's suppose you have a table with a complex data structure in one column, and you want to order it by a subcolumn or create a secondary index with a subcolumn of this column. And in previous versions, you had to access it as a function, like here. We used a function tuple element to access an element of a tuple. That is easy, that is natural, but how much better it is if you will write just like here. Without any function, just access it with dot syntax, with subcolumns, with arbitrary nesting, and it works. It works in 25.1. Now let's take a look. Why did we implement this feature actually? We implemented it for the new Json data type. With the new Json data type, it is really convenient when you access arbitrary fields, arbitrary arrays inside Json using these dots. and array subscripts syntax. And in previous versions, it was slightly unnatural. You had to do get subcolumn with this subcolumn path. Not a big deal, but still, it is much better in the release 25.1. You just type it as you thought it always have worked. Okay, another feature. This is really small, so let's not waste a lot of time on it. If you send a script into ClickHouse with a native protocol, like here. Here we have 2 queries, but you can have thousands of queries in a single script. We will record and log query numbers and line numbers. So this is the first query on line 2. This is the first line, this is the second line. And this is the second query on line 1, 2, 3, 4. It will be logged, it will be available in the query log, in the text log, so you can track the source of your queries. Another feature, and you will probably be surprised, why do we need it? Now you can send a lot of queries, queries like DDL, create, drop, rename, alter, optimize, queries that don't return any result in a single statement, and ask to process all these queries in parallel if possible. So you can, let's suppose you installed ClickHouse, in ClickHouse server, it is empty, and you want to quickly create a schema with thousands of tables for your continuous integration scripts for testing, or just to create a new service for a new customer, because we allow to create services on top of ClickHouse for your customers. And you just send all these queries in a single statement, and all of them will be processed quickly. It is actually implemented to speed up the restoration of backups, but it can speed up anything. Nice feature, right? Let's take a look. What is the next? And the next one is a possibility to specify indexes for all the columns when appropriate, like in a bulk. So let's suppose you have a table, you have a lot of columns, like 3 columns in this example. All of them are numbers, and you thought, why don't just create MinMax Index for all of them? And you do exactly this, and you have to do exactly this in ClickHouse version 24.12, in the previous version. In the new version, you can simplify this simply by enabling this table level setting. Add MinMax Index for numeric columns. It will automatically find all numeric columns and create a MinMax Index. Easy. But the point is, you don't even have to specify this setting on a table level. You can specify it globally on a server level. And all your tables that will be created will be speed up with indexes. And MinMax indexes are really lightweight. It's not a problem to have an index for every column. Maybe we will enable this setting by default in one of the next versions. Okay, what else? So many features. So many new features. A possibility to specify settings in a create table statement when the statement does not have an engine. So let's take a look. What is the difference? In version 24.12, if you write create table, order by something with certain settings, you can specify the engine as usual, but oftentimes you don't specify the engine. You just write order by, or even in the standard SQL syntax, primary key inside the table structure. And unfortunately, in the previous version, this query showed you an error unknown setting index granularity. That is ridiculous because I know about this setting. Mark, do you know about this setting? Index granularity, everyone knows.
I mostly know it because when you ask it how you created a table, it always returns that.
Yeah. So everyone knows about this setting, and it is ridiculous if ClickHouse tells you that it is unknown setting. And the problem, and the same problem when you type create table as, is that if you don't specify the engine, these settings are interpreted as query level settings, not table level settings. But actually, they are supposed to be table level settings. So we fixed this in version 25.1, and everything will just work even if you did not specify engine, even if you have written create table as. And you can even mix table level and query level settings. Now another small improvement. If you output a value of JSON data type, like here is the value, here is JSON data type in a JSON format. It will be printed by default. So in the previous version, it is output like here. In the new version, it is output like here. And I think it is much better, but if you disagree, just turn off this new setting, output format JSON pretty print. It is for presentational formats like JSON, JSON compact. If you use line-oriented JSON, JSON each row, JSON compact each row, it is not affected by this setting. It is like machine readable format. So it is as is. And yet another nice usability improvement. We have a lot in the new release, a lot of small improvements, small gifts for you. We will ask if you are accidentally or not accidentally going to output binary data into your terminal. So when you run ClickHouse client or ClickHouse local, as usual in a terminal, you can output data in a text format like JSON, pretty, CSV. It will work as is. You can dump the result into a file, like in this example. And in this case, it does not matter if it is a text format, if it is a binary format, it will work. But if you probably accidentally attempt to output data, binary data into your terminal in non-interactive mode, in interactive mode, regardless, it will just ask you, the format is binary and could produce side effects when output directly into the terminal. If you want to output it into a file, use the into-out file modifier or redirect the output of the shell command. And if you are sure, you will just type yes. Don't worry, it does not behave like an AI model. You can just answer yes, and it will proceed. Another nice feature. It is easier to show than to explain what it is. And let me show it. I will just copy paste this query into ClickHouse local. Here is my terminal. Here is ClickHouse local. And I run it using a shorthand syntax, shorthand name, CH. I like it. And here's the query. And you can see a new feature that if a value contains a trailing space, we will highlight this trailing space. So here it is. And it will be easy to distinguish. And what is especially nice, that we don't insert different characters, we make it even copy-paste friendly. So if I copy-paste, there is nothing. It's like magic, right? Let's compare because it looks so nice, but what if we will check how the previous version, how does it work? And the previous version, let me find it. Probably this. Yeah, this is the previous version. And in the previous version, you cannot distinguish if there is a trailing white space or not. And by the way, you can see yet another nice feature. Let me show it again. Another nice feature. Special rendering of multi-line values. Let me show it to you again. So in the previous version, let's output a few multi-line values. Here is a multi-line value, beautiful world. It is readable, it is okay, it works, but it is not especially nice. I like nice things. I like using nice things like ClickHouse. And in 25.1, ClickHouse became even nicer. So let's try it. And you can see, now it is so beautiful. And this multi-line value, beautiful world, it is pretty formatted as we want. And what is it actually for? For example, let's take a look in system table, system.functions. And there are 1,601 functions, including synonyms. But what is interesting, there is a inline documentation. And if we scroll up, there is not so much documentation, but if we scroll up, we can see that with the new format, this documentation is actually readable straight from this table. And you can read it right here. So accepts 3 parameters, dict get float 64, name of the dictionary, etc. I think it is nice. Okay, what else? Another feature for usability. Shortening column names if they appear to be too long. So let's do this query. It is a query for web analytics for one of websites. The data has been changed just in case. And here we calculate the number of users for today and tomorrow. Sorry, not tomorrow. ClickHouse cannot do this. For today and yesterday. And by default, if you did not specify a name for your expression, we will auto-generate the column name. And it can be quite long. And if it is long, we just shorten it. It works, and you will think that it always worked. But it is actually a new feature. And yet another nice feature. How many nice features do we have? I'm surprised. Better detection of compressed formats in a command line. you know that you can use ClickHouse Local or shortly CH to convert data between different formats, to process data on the fly, to process data in real time. You can even pipe a stream and it will output a stream of data. It's a really powerful tool. And in this example, I convert data from csv.gz to jsonlines.zst. So it will be compressed better, but using a different format. And here, both GZ and ZST are detected from file names. And you will be even surprised to know how is it possible. How is it possible for this command to know in advance from which files it will be read and to which file it will write? It is magic. And we did this magic. And obviously, you can use ClickHouse Local for data filtering, aggregation, pre-processing, transformations, whatever. It is a fully powered ClickHouse engine inside a small command line tool. And yet another feature, automatic squashing of blocks in pretty formats. So have you ever wondered why sometimes when you write a query in ClickHouse client, it will output multiple blocks? And what is the answer? Why it sometimes output multiple blocks? Mark, do you know?
I don't know, but I really want to know. Like, how does it, for this particular one, how does it, yeah, why does it do that?
Everyone wants to know, and everyone asked this for years.
Does anybody know though? Let's see.
Yeah, let's ask the audience.
I always end up like putting the pretty mono format to force it to squash. One output block per node for replicated tables, says Ruben.
Okay, let's take, say, 2 or 3 answers.
Todd says partitions. Although I don't know how that would apply here because we've got system numbers. Ah, Rafi says parallel computation. That sounds like could be a good one.
Okay, we have 3 answers. And I can say that all of these answers are correct. But let me give you an answer. ClickHouse outputs multiple blocks because there are multiple blocks. Let me explain. So ClickHouse does data processing by small chunks, blocks in memory. These blocks can be quite small, like 65,000 of records. Sometimes they are smaller. Let's say you read from a table, you read by 65,000 of records, and then you filter these blocks. And in a result, you have smaller blocks, maybe 1 record, maybe 2 records. But it is not what the user expects. Because why should they care? We are developers, we often want to know what are the actual blocks. And it is quite nice because if you have a long-running query, like a streaming query, it will output these blocks as soon as they arrive. But okay, let's take a look what has changed. How does it look in the freshest ClickHouse release? And it looks like this. A single block. You don't have to worry, you don't have to care, but you would ask, what about streaming? Does it have to buffer the result? And actually, it works even with streaming, and it does not have to buffer the result. again, it works in every case. It works as you expect. So let's take a look, and instead of this, we will do a much harder query. It works perfectly. So when you have a large amount of time between blocks, more than 100 milliseconds by default, it will output these blocks. And what is more interesting, it does not even delay this output, so it will be immediately. I even cannot believe that it works this way, but now this problem is solved. Okay. And yet another nice feature, and I have to show it. First of all, let's open the previous version and run this query. And it is output in a pretty format, and it is a table, and it is a pretty readable. So there are many, many columns. And for example, let's try to read the column, name it. It's difficult to read actually. Let's try to read it. So lifetime bytes, apparently it is null. It is on the same place. The sampling key is also null. And the name is tables. Actually, let me open another table. It will be easier. So the comment is lists all tables of the current server. Nice. So it is readable already. What has been changed? In the new version, it looks like this. So it automatically detects if you have just a few records, like one record, but a very wide table. And if it is the case, it will output in a vertical format. And we can read it much easier. So the comment is here, the total rows is here, the name is here. Sometimes it could be surprising. So you can always change it. You can always disable this behavior if you don't like it. But I used it for 2 weeks already, and I like it. It is so nice. So should you. You like it too? Okay, what about query performance? What do we have? We have a lot of improvements. The first one is about joins. I promised that every ClickHouse version will improve joins performance. And here we improved parallel hash join. It is faster, but how faster? I have to experiment. I prepared a few queries, synthetic queries, just to demonstrate this feature. So let's start again with the previous version. I will create 2 tables, test1 and test2, with some numbers, strings, low cardinality strings, and I will do inner join. Actually, I don't have to write join algorithm parallel hash because it is the default. Let me remove it. It should work as expected by default. 0.2 seconds. The table already exists. Let me try one more time just in case. 0.2 seconds. Now, if I run the new version, let's check how faster it is. How faster?
Yeah, I
Mark.
need some guesses. So 0. Was it 0.2 on 24.12?
Mm-hmm.
What is it going to be on 25.1? 0.05 says Mikhail. Anybody else? 0.08 says Ruben. 0.0002 says Rafi. Rafi is very optimistic for this query. I don't even know if it measures it that. That would be like, yeah, it doesn't measure that for that many decimal places, does it? It's only 3. So I'd have to say 0, 0. 0.16 says Goran. I think we got, I will say, oh, I don't know. 0.07. I'll say 0.07.
Okay.
What do you say? Or do you know the answer already?
I would say that some optimizations are really hard to do. They require a lot of efforts just to squeeze a little bit of performance. And we always appreciate these optimizations. And to know how faster it is, let me just run it. Maybe it will be slower. Oh,
0.13.
0.134. Is it like
Goran is the closest.
Okay, do we have special gifts for best guessers?
Maybe we get a special gift. We need Tyler to send a message. Tyler will send you a message, Goran.
T-shirts, hoodies, hats.
I don't know. I don't know what. Yeah, I don't know what's on offer. What's the email that you need to? Oh, there you go. Tyler@clickhouse.com. Maybe we do another question later and see if we can get someone else to win.
Okay, another optimization is for a new feature that only recently became beta after being experimental. Faster vector indexes. So in ClickHouse, you can use it like a vector database. So you use an AI model to generate embeddings for your comments on your website, for some articles that you sell, for images, videos, whatever, anything. And you store these embeddings in multi-dimensional arrays. Then you just search inside these arrays using cosine similarity, dot product, or L2 distance. This is what vector search is. And ClickHouse is already quite fast for vector search, especially if you use the right data types like bfloat 16. But you can also use indexed vector search. But in the previous versions, there was one small complication. While it was already faster than a full scan, ClickHouse was loading index from disk to memory, or from cache to memory, or just deserializing this index and building deserialized state in memory every time. Every time you run a query, it will just bring the index from something to memory. And it is pointless if you have many queries. So we implemented the cache. And it is faster, but not just faster. In the previous version, it was 33 seconds. And in the new version, it is 64 milliseconds. So it is about 500 times faster. And yet another optimization now for parallel replicas. Let me remind you, parallel replicas is a feature you can enable with the enable parallel replicas setting. It's easy. We have good names of the settings. It allows you to use resources of all replicas that you have in the cluster. And it is especially useful if you have a shared everything architecture when every server is a replica, and you can change the number of replicas to any number you want, like in ClickHouse Cloud. And now parallel replicas are 40% faster on ClickBench. And the main focus, to make sure that even very short queries are faster if you increase the parallelism. It is like a usual challenge. When you lower the latency, it is difficult to increase the throughput. If you increase the throughput, it is difficult to sustain low latency. But Igor and Nikita showed that it is possible. It is possible to make more and more improvements. Yet another feature for performance. It is difficult to explain, but let me try. ClickHouse has a debugger and profiler embedded into the binary. And this profiler, it is always on. It works by default. And it collects historical data about every query that was run, about where every query has spent most of the time. And it does it by sampling. It takes a random time points and record stack traces inside the code. It means locations in the code base where at this specific time point, every thread of execution inside the server spent the time. It exists for 5 years already, but now we have one small improvement. So in the previous version, it collected addresses in memory, like pointers. And these pointers, you can convert these pointers to function names using address to line and address to symbol functions in your SQL. You just query this table, you convert pointers to function names. That is easy. But the problem, this conversion is invalidated as soon as you install a new release or a new build. And this way you just lose historical information about this profiling data. In the new release, there is an option, and it is enabled by default, to symbolize and persist symbolized addresses in the same table. You will have function names and lines inside the code base stored for every release, and it will be easy to compare historical data. And to be frank, I did this feature for myself and for my colleagues, because it will be much easier to monitor the performance of ClickHouse Cloud. But you can use it too. Okay, now about the top features. Something really interesting, really exciting. The first one is lightweight updates. This is easy to explain, easy to use. Just enable apply mutations on the fly. And when you do a mutation like alter update or alter delete, your queries will not wait for these mutations to materialize. They will initially just apply them on the fly. You do a select query. If mutation is still pending, the select query will just apply this expression. With the cost of a small slowdown on select, you get a large speed up of mutations. And by the way, this feature is not new. It was enabled in ClickHouse Cloud for more than a year. We just implemented it for our usual merge tree and replicated merge tree engines, because initially it was implemented just for a shared merge tree, but there was no intent to keep it proprietary. It was initially planned for everyone. We just had to finish the implementation. And this is what many people dreamed of if they used to use MySQL or Postgres. Auto increment. Let's take a look. This table have this ID column auto-generated by auto-increment. And it is implemented with a new function. The new function is named generate serial ID. And here is the name of the series. And it will generate this series in a parallel and distributed fashion. It is safe to define even for replicated tables. The numbers will not intersect. It is also quite efficient. It will do just a single request to a keeper when you do a single insert. And you can even use it without a table. You can even generate series in just a select query. So let me show it. Now I have a server, and this server, here it is. It is connected to ClickHouse Keeper. It is connected to ClickHouse Keeper, and I will just copy-paste queries from the slide. Let me name the series somehow like this. Table test already exists. Let me drop it. And now I just insert a few records. I have a mistake on the slide. No problem. And let me see if it works. It works. Let me insert more. Perfect. No surprise here. Actually, my demos are really boring because
I got a question from Mikhail. Is that generate serial ID? Is that like on a table basis? So if you create another one, it will be completely starting from zero again. Can you do one, and then can you do one which covers multiple tables, or is it per table?
Yeah, it is interesting because it actually does not depend on a table. So here I defined the series name exactly as the table name. So it will count for this name, for this identifier, but I can create another table and use another series, or I can create two tables but share the counter between them.
Oh, clever. Huh.
And you know what? It is funny because if I do what is supposed to be in the test, it will output 1.25 billion because I used this identifier for my tests. And keep in mind, these generated auto-incremental numbers, they will be monotonic, they will be unique, but they don't have to be consecutive. They can have gaps if you did an insert and this insert did not went through, the series ID can be incremented and a certain interval will be skipped. But you will get all the guarantees that you expect. And here is another feature, and it is a big deal. And maybe it is not really obvious, not really evident from these examples. And maybe you even thought that it was always this way. But let me explain. Improvements for merge tables. To remind you, the merge table engine is an engine that allows you to unify multiple tables as a single table. In this example, I created two tables. Then I create a merge table that will point to the current database and choose tables by a regular expression. And this regular expression will match this two tables. When you do a select from a merge table, it will select from every table. You can also use merge table engine as a table function without creating a table. The table function looks like this. You just write from merge with some parameters that can also include database name optionally and a regular expression. And the change is as follows. In previous versions, the structure of the resulting table was inferred as the structure of the first table. So here we have two columns, A and B, but the second table has the same column A with a different data type, and it does not have column B. Instead, it has a column C, again with a different data type. Let me just show it to you. How it works in the new version. Let me do show table. In the new version, the structure is unified. You have all three columns, A, B, and C. I don't know why in this order, but the point is all columns are present, and even data types are unified. It can even unify data types of incompatible types, like integers and strings. And why do we need this feature? Because merge tables are really handy for schema evolution. Sometimes, instead of doing open table, you just create more and more tables, and you have a single merge table that unifies everything. Okay, and yet another feature that could be difficult to explain, but easy to show. Streaming data formats and streaming results over HTTP. So we have a data format named Json, each row with progress. And actually, it is not a new data format. It already existed. And it outputs not just data, but it outputs events of different types. Here we have a progress event, a lot of progress events, metadata event, row event for every record in the result, and even totals event because we have group by with totals. And each event is a new line delimited JSON with the name of the event and a payload. So it works even with chunket transfer encoding. It properly flushes the data so it will arrive to the client as soon as it appears. It even works with compression. Even if you compress the data heavily with ZSTD and you have progress events, don't worry, these progress events will arrive in separate chunks. And the easiest way is to show it to you. I have just a few minutes to show, but it is so amazing. So let's take time. The best way to demonstrate is to use the embedded user interface. Here it is. And first of all, let me show the changes. So I will do this query that does sleep for every block of data. And if you have used this embedded web UI before, you will see the changes. First of all, there is a progress bar. I like this progress bar so much. It was only in ClickHouse Client before. Now, it is in your browser. And it is a real progress bar that displays the data as soon as it arrives. And the result is also streamed. So we will not wait for all the results to be done, to be ready. We will display it as soon as possible. And there are even certain events that allow us to show this nice chart. But it is just a toy example. Let me show it on some more interesting queries. So let me select from a large table how many events on GitHub I ever did. Such a nice progress bar. And I did 100,000 of events. Let's take a look also at the dark theme because it is even nicer. You can see that even the design of this UI has been updated because my goal was to just test the progress bar, but I did not hesitate to also just change a lot of small things to make it nicer for me. And in the dark scheme, you can see this. It is so beautiful that I have to run this query multiple times. It is a yellow progress bar. Did you ever see a yellow progress bar, Mark?
I don't think so. I think it's first one. Must be frustrating for you though, because mostly the queries are so fast you don't get your progress bar.
Yeah, most of the time you don't see the progress bar, even despite it processed 8 billion records and 17 gigabytes of data. Let's try another query. So here I will find repositories where I left comments if this repository is not related to ClickHouse. Oh, how nice it is. But what I wanted to show that the result is also streamed. So here it is. It is still too fast, but yes, it is streamed. What is also interesting now, it allows me to cancel this query anytime. And yes, query was canceled. So the progress bar, cancellation, result streaming, everything works thanks to this format. Let's try some query that is slightly slower. I want to search comments from my colleague on GitHub on any repository other than ClickHouse. Just one of my colleagues. Okay, so this person, which is my friend, contributed to Apache ORC, DB benchmark from DuckDB Labs to put ClickHouse in the first place, and ACM, and OSS FAS, and LLVM. Okay, everything is perfect. Now back to the slides. What do we have as a bonus? Our official roadmap for this year, for 2025. It is ready, it is published and ready for discussion. Oops, I have to sign in and I will not do it. Instead, just go to our repository, read the roadmap, and start dreaming about it. And we will do it. We already implemented a few items from the roadmap because it is already well past the start of the year. And another thing, CHDB release 3.0. Just to remind, CHDB is a full ClickHouse engine packaged as a small library for Python and for other programming languages. So you can process data frames, you can process any data set, external data. You can do whatever data science, combine it with pandas, combine it with any notebooks using CHDB. It is really powerful. I would say the most powerful analytical table and analytic query engine for Python, the most powerful embedded analytic engine. And now it is faster, 20% faster in the new release. Now it is also more compatible. There are a lot of compatibilities, so if you get used to use SQLite, you will find CHDB almost like a drop-in replacement. And yet another nice thing, now it is about ClickHouse Cloud. In ClickHouse Cloud, you can create a service, you can change its scale anytime, but now you can create multiple sub-services for the same data. And these sub-services can be configured with a different scale, with different number of replicas. They could be configured read-only or read-write, and they don't affect each other. I would say almost. Read-write services can run merges from inserts, run on another service, but let's suppose you have a read-only service and you can create it for heavy queries, for heavy ad hoc queries, and just not worry. This is the point. And this is a really nice feature. I strongly recommend to read about it, to try it. What else? I almost forgot about it. We also speed up Iceberg. ClickHouse works with data lakes. ClickHouse is one of the best engines for data lakes. And now we sped up reading from Iceberg, and I will not tell you how, because you have to try it. You have to install 25.1, and you will see the difference. And a lot of changes for integrations, like for Grafana and for our Go client, we support the new data types, Json, variant, and dynamic. And we have a lot of meetups. As soon as day after tomorrow in Croatia, but also we will be present in FOSDEM with 3 presentations, meetups in India, in London, and in Dubai. And this is only for the next 2 weeks. And a lot of nice things to read. My favorite is this article, Evolution of the Cloud. It is about how our service has been optimized over 2 years. How faster it, how the infrastructure behind it has changed. There are more articles like how do we test ClickHouse with BuzzHouse. And even customer stories as usual, and a lot of customer stories. And now, 1 minute for Q&A.
Let's have a look. Okay, so this, when you were doing the merge table, how does it work with alias columns?
They will unify these columns. So if you have an alias in one table, but don't have it in another table, it will just put this alias. If you have an alias column in one table and regular column with the same name in another table, it will use the regular column. And finally, if you have an alias with the same name, but different expressions in different tables, it will use the first expression.
Cool. And when it's using if it uses the variant type, if you had 2 columns of different types, do you have to make sure you enable the variant type with the setting in order for that to work?
Most of the time, you don't even have to enable it. Somehow it works. But
okay.
In some cases, you will have to enable it.
Okay. And then another question, Mustafa, what is the status of writing to Iceberg tables?
Currently, ClickHouse cannot write to Iceberg tables. And from my experience, it is all very, we will have to resort using other systems like Spark. And using Spark is not a pleasant experience, especially for me. Just going through all of these configuration options. If you use Spark, maybe from 20th try, you will be able to write into a table. But I also recommend to try the new feature from AWS, Iceberg tables. Maybe it will be helpful. We are going to implement writing to Iceberg in this year. It is in the roadmap because I'm not satisfied with the state, how all the landscape is today. We just want to make it simpler and more performant.
Okay, a question from Shir. This is kind of going back to the tracing. So does tracing also trace queries off materialized views?
Tracing like query profiler or whatever. Query profiler works universally. Whichever queries you have, even intra queries.
Trying to remember, what was the thing? Trace log. Yeah, it was trace log.
Yeah, the trace log works all the time for regular queries, for materialized views, for complex queries, and even for refreshable materialized views, everything should work.
Okay, let's do one more. So the question was, can you, instead of using table names with the merge function, can you give it file names so I can search, convert to JSON, and transfer files in a directory?
Yeah, absolutely. And this is the use case for ClickHouse Local. And in ClickHouse Local, it even makes the files available as tables. But I would also recommend to create tables with a file table engine. So you create table, say, my table as file, my table.json. And now this table represents a file. And then you create a merge table on top of these tables.
So you could have like a file for one folder, a file for another one, and then join them together.
Yeah, for sure. In ClickHouse Local. So if you want process local files, you use ClickHouse Local. In ClickHouse Server, you can also place files in a specific directory just for processing them.
But then that has to be on the server, right? If you do that. So.
Yeah. You can even combine processing on the server and processing on the client. You run ClickHouse Local and query your local files, and also query the server with the remote table function. It is named hybrid query execution. It is available in ClickHouse Local since 2017.
Cool. Another one. I think, did we talk about this in the last one? Someone says, any plans to integrate reading from the Unity catalog? I thought we might have talked about that in December.
By the way, it already works for Iceberg. I even showed it on the previous release call. You can watch.
Yeah, so go back and look for the December one. Maybe I'll see if I can quickly find you a link.
Yeah, what we still have to do is to implement using Unity catalog for Delta Lake tables. But for Iceberg, it works thanks to the compatibility mode of the Unity catalog.
Here, I'm going to put in a link for all the previous ones. Cool. I think let's, we're a little bit late, but I think let's wrap it up there then. I think we got to most of the questions. Cool. So thank you everybody for joining us today. And yeah, we posted the YouTube link already, so you can find it if you want to watch anything you missed or watch it again. Otherwise, we'll see you in February.
Thank you for